Okay, in this video we're going to be factoring again. Now we've already reminded you about some of the factoring that you've done in the past, and we're going to go over that again. And in addition to that, we might look at a few new factoring methods that you maybe have never seen before. So first off, reminder: factoring is the process of breaking apart a binomial, trinomial, polynomial into the product of factors. And we looked at a little bit of that actually last section. So what we're going to do first off is how to factor out a GCF. Well, first off, how to find a GCF. Start with your numbers. The largest number that will divide into 12 and 10, which will be a 2. And then if your terms ever share variables, you'll take the lowest power of those variables, and that's going to be part of your GCF as well. And we are now going to factor out the GCF by saying 2a squared, we're doing distributive property backwards. 2a squared times what and times what would give you these two factors. And first off, we know that 2 times 6 is 12. And we need 3 a's. 2 of them are out here, so I need one more. Let's put it on the inside. Plus 2 times 5 would be 10, and I need 2 a's, and they're both on the outside, so do not put any more a's in here or you'll have too many, and that's it. You're done. 14 to 7, GCF is going to be 7. M to the 8th, M to the 2nd, always take the lowest power. They also share ends, always take the lowest power. 7 times 2 gives you the 14. You need 8 M's, you have 2 on the outside, so put 6 on the inside. You need 5 N's, there are 2 on the outside, so put the other 3 on the inside. 7 times a negative 1 gives you the negative 7. You need 2 M's and 2 N's, and they're both on the outside, so you don't need to put any more on the inside. Okay, next up, perfect squares. Let me remind you what we mean by perfect squares. Your perfect squares are 1 to the 2nd power, 2 to the 2nd power, 3 to the 2nd. So all those numbers, 16, 25, 36, we'll go through maybe 225, something like that, 49, 64, 81, 100, 121, 144. Let's see, 13 times 13 is 169. 14 times 14, 196. 225 would be 15 times 15, and those go on forever. Now, the rule is to factor difference of squares. First off, you have to have a perfect square minus a perfect square. And the rule is if you have a perfect square minus a perfect square, difference of squares will always factor into conjugates, plus and minus. It's going to be what multiplies to give you a squared, which would be in this case an a times an a, and what multiplies to give you a b squared, which would be a b times a b. So difference of squares factor into conjugates. And if you don't remember what conjugates are identical factors. The only difference is going to be the plus sign and the minus sign. Okay, let's start out with number 3, and let's factor a difference of squares. Is this a perfect square? Yes, because 3x times 3x would multiply to give you 9x squared. Is this a perfect square? Yes, because 7y times 7y. Difference is the subtraction. Difference of squares will always factor into conjugates, so you can go ahead and put the plus and minus and simply ask what multiplied by itself to give you 9x squared was a 3x times itself. What multiplied to give you 49y squared was a 7y times itself, and you're done. Number 4, is this difference of squares? No. 72, you can't multiply anything times itself to give you 72 or 2. Now, c to the 4th looks good. However, step number 1 to factoring is always figure out, is there a GCF that I can factor out? And in this case, there is. 72 and 2 have a 2 in common. So let's factor out the 2. You're left with a 36 and a c to the 4th. Factor the 2 out of the 2, leaves you with a 1. Now what you're left with is difference of squares. And let me draw that 4 a little bit better. Bring down the 2. Difference of squares will factor into conjugates, plus, minus. What times itself gives you this would be a 6 and a c squared times a 6 and a c squared. What times itself? What times itself gives you a 1 would be a positive 1 and a positive or a negative 1, and you've got it. That's factored into difference of squares. Number 5, GCFs would be there's a 7 in common. Take the lowest power of m that's in common. Take the lowest power of n. 7mn times what would give you this? 7 times 1 gives you 7. So you can put the 1 there if you'd like to, but you don't have to. I need 7 m's. I have 1 on the outside, so I need 6 on the inside, and I need a single n, and it's on the outside. Minus 7 times the 4 gives you 28. I need one m, it's out here. I need 3n, so I need 2 more on the inside. What I'm left with on the inside is difference of squares. Difference of squares factors into conjugates. The reason it's difference of squares is because m to the third times itself gives me this, and 2n times itself gives me this. Number 6, common factor is a 10. Lowest power of w is w to the first. 10 times 1 gives you the 10. You don't have to put the 1 because we're going to have a w to the fourth because we need 4 more w's on the inside because there's 1 out here, 4 more on the inside. Minus 10 times, we will need to put a 1 here because if we don't, nothing else will be left there because I need a single w and it's out here, and then the 10 times 1 gives you the 10. So now here we go. Is the inside of parentheses difference of squares? Yes, because this is a perfect square and this, conjugates. This is a perfect square because w squared times itself gives you w to the fourth. Then you have a positive 1 and a negative 1, or 1 times 1 gives you the 1. However, we're not done because look what I have here. Difference of squares again. A lot of times when you're factoring a w to the fourth or w to the eighth or something like that, you might end up having to do this twice. Now, this is not difference of squares. This is a perfect square, this is a perfect square, but this is not a difference sign. It's an addition sign, so that will not factor again. Now, the second set, difference of squares, will factor into conjugates. W times itself gives you w squared, and 1 times itself gives you 1. Okay, in the next section, we're going to be doing sum of cubes. Now, let's go over what we mean by perfect cubes. That'd be 1 to the third power. A cube is anything raised to a third power. 1 to the third, 2 to the third, 3 to the third, 4 to the third, 5 to the third. Now, these grow a whole lot faster than the squares did. 6 to the third is 216. 7 to the third is 343. 8 to the third is 512. 9 to the third is 729, and then 10 to the third is 1,000. That's about all we have room for. And here's your rule for sum of cubes. If you have a perfect cube, such as one of these numbers, plus another perfect cube, and that could be an x to the third or an x to the sixth or an x to the ninth, those are all perfect cubes, it will always factor into a plus b times a squared minus ab plus b squared. Very important that we understand this formula. Now, here's what I like to do just to make it fit the formula. I like to rewrite this. Now, this one's already in the right form. I'm going to leave this as x to the third plus, now 27, that's a perfect cube, and you can see it's your list. 27 is the same thing as 3 to the third, so let's write that as 3 to the third. The reason why, because now I can see in my formula. My a value for my formula matches up with the x. The b in my formula matches up with the 3. So all you have to do is everywhere you have an a in the formula, put x. Everywhere you have a b, put a 3. So this a plus b turns into x plus 3. Then you have a to the second, which is x to the second. Everywhere I have an a, put an x. Everywhere I have a b, put a 3. Minus a times b would be x times 3, or we can just put 3x. Then finally, b to the second, here's our b, was 3, so b to the second will be 9, and you're done. Now, when you're factoring with difference of cubes, or excuse me, sum of cubes, this will not factor. So you don't even have to worry about saying what adds to give you this, multiply. There's not going to be anything. Okay, next up, is this sum of cubes? Yes, it is. Now, let's rewrite it in the form so that it matches our formula. I know this is already something to the third, plus 216 is 6 times 6 times 6. So that's 6 to the third. So this whole thing is a 6 and an n to the third power. This is a 6 to the third. This is an n to the third. So I'm going to put that in parentheses as a 6n to the third. Now, you can see you could raise both of those back to the third to give you this term. So let's leave it like this. So again, now it fits my formula. Everywhere I have an a, I'm putting an m. Everywhere I have a b, I'm putting 6n. So a plus b is now m plus 6n. If I have an a, I'm putting an m. So times m to the second minus a times b would be this times this. Now I'm going to put these letters in alphabetical order. So a 6, an m, and then an n. Now probably the hardest part, now we got to do b squared, but it's still easy. Here's my b. Whenever you square it, make sure you square each piece. So that'd be a 36 and an n squared, and you're done. Number 9, is this a sum of cubes? Not yet, but let's go ahead and factor out. I believe the 4 is in common. So pull out the 4. You're left with a 125a to the third plus 1. So now, yes, we do have sum of cubes. So let's look at our formula. So there it is. So let's go ahead and bring down the 4. And let's write this again in our form that's going to match here. Instead of 125a to the third, I know that 125 is 5 times 5 times 5. So I could write that term as a 5 and an a that's being raised to the third power. And then the 1, that's pretty easy. That's a 1 being raised to the third power. So my a in my formula matches up with 5a here. Don't let the a's throw you off. The b is 1. So everywhere I have an a, I put a 5a. Everywhere I have a b, I put a 1. So a plus b will be 5a plus 1. A to the second will be 5a to the second power, which make sure you square both. It would be a 25 and an a squared. Minus, now you got to do a times b, which is 5a times 1. And then plus b to the second power will be 1 times 1, which is 1. And that's it. Number 10, I'm going to leave it right here so I can still see my formula. Step number 1, let's see if there's anything in common. 24 and 375 has a 3 in common. The lowest power of c in common is c to the first, and the lowest power of d is d to the first. So let's factor this out. You're left with an 8. You need 4c, so that'll be 3 more on the inside. Plus 3 times 125 is 375. I need a C, and it's on the outside, and I need a total of 4D, so I need 3 more on the inside. So these are, again, both perfect cubes. The reason why, this is a 2 and a C that's being raised to the third, and this is a 5 and a D that's being raised to the third. So what I've done when I've said that is in my formula, there's my A and there's my B. What's being raised to the third and what's being raised to the third. So now to factor this, let's bring down 3CD. Everywhere I have an A in my formula, put 2C. Everywhere I have a B, put 5D. So A squared would be 2C times 2C, which is 4C squared, square them both. Minus, I now have to do A times B, which would be 10CD. Plus, B to the second would be this times itself, which would be a 25D squared. And that's completely factored. Now, the next part is going to be very similar to that. Now we're dealing with difference of cubes. The sum of difference of cubes looks a whole lot like that formula. A to the third minus B to the third is A minus B. Now, that's different. And then A squared plus that sign right there. That is the only difference between the two formulas. A squared plus AB plus B squared. So let's do the exact same thing. Let's rewrite this in the other form. X to the third minus 1 is the same thing as x to the third minus 1 to the third. So all we do is everywhere we have an A, put an x. Everywhere we have a B, put a 1. So A minus B would be x minus 1. And again, the only difference here is instead of sum, you have difference, okay? Now, don't get it confused with difference of squares because there is not a sum of squares. A to the second would be x to the second plus x times 1 would be 1x, and then plus 1 to the second is 1. This is a perfect cube, and so is this. So we can rewrite this as a 6 and a k that's being raised to the third. And this is a 5 that's being raised to the third. So in my formula, in the place of A, I have a 6K. In the place of B, I have a 5. So everywhere I have an A in my formula, we put a 6K. Everywhere I have a B, I put a 5. And that's it. We have to square A, so we're squaring 6K, which would be a 36 and a K squared. Plus, we got to multiply A times B. Now, I'm only dealing with this. Don't get confused with this negative sign here. Only the A and the B. 6K times 5 would be a 30K. And then I've got to square plus my B squared to be plus 5 times 5 would be 25. Number 13, and I'm going to go ahead and recopy my formula here. Now, let's rewrite this. Well, first off, this is not difference of cubes. However, I can factor it a step further. I can pull a 4 out of both of these, and I'm left with a 1 minus 8h to the third. Now it looks good. Let's rewrite our 1 minus 8h to the third. 1 is a 1 that's being raised to the third power. Minus is right here. The 8 and the h to the third is a 2 and an h that are both being raised to the third power. So here's my a, here's my b. Simply replace it now. A minus b times a to the second plus a times b would be 1 times 2h plus b to the second would be 2h to the second would be 4h squared. Number 14. Factor out any common factors. There is a 2 in common. Let me draw a line there. Pull the 2 out. You're left with an x to the third minus a 27y to the third. Again, look at your formula and let's identify what our a and my b is. Let's rewrite this thing. This is the same thing as an x that's being raised to the third, and this is a 3 and a y that's being raised to the third. So therefore, my a value in my formula is x, my b value is a 3y, so now let's just start plugging them in. Now this 2 just gets copied over, and you have a minus b times a squared plus an a times a b, so I've got to multiply this times this, that would be 3xy, put them in alphabetical order, and then plus b to the second would be a 9y squared. Okay, next up we're factoring trinomials, and you've seen these before, but we're going to do them again anyway. With a trinomial, if the number out front's a 1, all you have to do, 2 sets of parentheses, and you simply ask yourself what multiplies give you n to the fourth, that's an n squared and an n squared. What adds to give you this and multiplies to give you this, and that finishes it out. That would be a positive 6 and a negative 4. Now, they have thrown this at you. Let's see if that factors again. If you're left with n squared, if this is not linear or n to the first, see if it'll factor again. Is this, if it has 2 terms, the only way you can factor this is it difference of squares or sum or difference of cubes, and it is not. However, this is. This is difference of squares. Difference of squares factors into conjugates. N squared is an n times itself. 4 is a 2 times itself. And now it's finished. 16, always look for a GCF first. This has a w in common, the lowest power. W times w squared gives you this. W times a w gives you this. And w times a negative 20 gives you this. And then what you are left with, then you see, will this trinomial factor? W times w does give you the w squared, but what adds to give you 1 and multiplies to give you negative 20 would be a positive 5 and a negative 4. Number 17 has a 2 and an a in common. 2a times what gives you this? I need 2 more a's, so a squared. 2 times 19 is 38, and I need 2 a's, so let's put 1 more on the inside. And 2 times a positive 34 gives you the 68, and I need 1a, and it's on the outside. Now let's see if the trinomial will factor again. 2 sets of parentheses. A times a gives you a squared. Adds, multiplies is a positive 2 and a positive 17. These are now linear factors. It's a to the first, so you don't have to try to do it again. 18 obviously has an x in common. So let's factor it out. You're left with x to the fourth minus 24, x to the second minus 25. Then you ask yourself, trinomials, 2 sets of parentheses, x squared times x squared gives you x to the fourth. What adds, multiplies is a negative 25 and a positive 1. See if any of this will factor again. This is difference of squares. Difference of squares factors into conjugates. X times itself gives you the x squared. 5 times itself gives you the 25. This is nearly difference of squares. However, since it's a plus sign, it will not factor again. There is no such thing as sum of squares. Number 19. Look for common factors. There are none. So this is where you use what's called slip and slide method. Take a number out front and move it to the end by multiplying x to the fourth plus 14x squared minus 15. This is actually a shortcut. You could use what's called trial and error, which is a little bit tougher. I will introduce you to trial and error. This one might not be too bad. You ask yourself what multiplies give you 3x to the fourth. That'd be a 3x squared and an x squared. And then what multiplies give you negative 5 would be like a negative 5 and a positive 1. And you see if that works. And if you don't see if that doesn't work, then you start switching stuff around, and maybe this is +1, this is -5, and you do that until you find something that does work. Again, that's called trial and error. Let's use slip and slide instead. Two sets of parentheses. X squared times itself gives you x to the fourth. Adds multiplies is a +15 and a -1. The number that you slipped, you now divide by. If it's divisible, as it is in the first one, you actually divide. 15 divided by 3 is 5. If it's not divisible, like here, you try to reduce it. If it doesn't reduce, you slide the bottom back up front, and you have 3x squared minus 1. Let's see, do I have difference of squares? No. Do I have difference of squares? No, it nearly is, but because of that 3, it is not, so therefore you are finished. Even though it's quadratic still, that's as far as it'll go. Another slip and slide problem here. There are no common factors, so let's rewrite it as m to the fourth minus 12m to the second. Slip the 9 to the n. And I believe you actually have a perfect square trinomial here. M squared and m squared adds multiplies is the same, -6. You slip the 9, so divide by the 9. It will not divide, so you try to reduce it. Divide top and bottom by 3 gives you 2/3. The second set of parentheses will be the exact same thing. Once you finish dividing and reducing, if there's anything on bottom, move it back up front, slide it, and you're left with 3m squared minus 2 times itself, so you can just put a square there. Now the question is, will this factor again? It's not difference of squares, it's not sum or difference of cubes, so therefore it will not. Okay, the last section, what do we do when we have 4 terms? And this is the rule, we're going to use grouping. And here's your steps. Step number 1, we're going to group the first 2 terms together and the last 2 terms together. So here's my first 2 and here's my last 2. I usually just draw lines under them. We're going to factor the GCF for each group. The first group has lowest power of x is x squared in common. You're going to factor that out, and you are left with an x and a +1. The second group, you have a -4 in common. When you factor it out, you're left with an x and a +1. The rule is if both, again, here's my groups, if what you factored, once you factored out, what you're left with in parentheses are the same, it worked. You can do this. Now, you can't always do it, but this one did work. What you're now going to do, out of these 2 groups, you're going to factor out that common thing in parentheses. This had an x plus 1, this had an x plus 1. Once I factor that out of this, I ask myself, x plus 1 times what gives me this? And that would be an x squared. X plus 1 times what gives me this? And that would be a -4. Now that would factor again, but that's going to be the steps as what we were just going over there. So let's try a few more. 4 terms, factor by grouping. We're going to factor an x squared out of the first group. You're left with an x minus 1. We're going to factor a 9 out of the second group, and you're left with x minus 1. Since both groups are left with an x minus 1 in parentheses, we now factor it out, and you're left with an x squared in the first group and a +9 in the second group. That will not factor again, so you're finished. Number 22, group them. First group, you have a k squared is the lowest power of k. Factor that out, you're left with k plus 5. Second group, you have a -1 in common. Even if nothing else will factor out, try to factor out a -1. And if not, you do have to at least put a +1 that you factored out, or this won't work. -1 times k and -1 times a +5 is what you're left with. Both groups, again, in parentheses, have the exact same k plus 5. We're going to factor out of each group. K plus 5 times what gives you this? K squared. K plus 5 times what gives you this? -1. And that's it. Now, I am going to go a step further with this. K plus 5 is finished. Bring it down. However, k squared minus 1, that's difference of squares. Difference of squares factor into conjugates. K times k gives you k squared. 1 times 1 gives you 1. So therefore, that's the finished product. 23, group. First group, least power of v is a v squared that's in common. You're left with a 4v and a -5. Second set of parentheses has a -4 in common. You're left with a 4v and a -5. Both groups have the same thing in parentheses. Let's factor out that 4v minus 5 out of both. Here, 4v minus 5 times what gives you this term? It'd be a v squared, and the second one will be a negative 4. You're done with the factoring by grouping. However, this is finished, but this is not. V squared minus 4 is difference of squares, which factors into conjugates. V times itself gives you v squared. 2 times itself gives you the 4. Number 24. Factor by grouping because it has 4 terms. 2x to the 4th is your GCF. 2x to the 4th times what gives you 2x to the 5th would be an x. 2x to the 4th times a negative 9 would give you the second term. This group has a 7 in common. Factored out, you're left with an x minus 9. Both groups have an x minus 9. When you factor it out, you're left with a 2x to the 4th for the first group and a positive 7 for the second group. And that will not factor again because this is not difference of squares or sum or difference of cubes. That's the only way that you can factor 2 terms.